Have you ever stopped to think about what's really powering a monster service like Amazon.com? We're talking billions of transactions, millions of people all at once, and a shopping cart that can never, ever fail. Well, the answer lies in a piece of tech that was literally born from a crisis. Amazon's secret weapon, DynamoDB. So let's rewind the clock to 2004. Amazon was exploding, right? Growing at this unbelievable rate. But here's the thing. That success was creating a huge problem behind the scenes. You see, their traditional Oracle databases, the tech that ran everything, just couldn't handle the load. They were starting to buckle under the pressure, threatening to take down the entire Amazon experience. So you can imagine the pressure on Amazon's engineers. They were faced with this monumental question. How in the world do you build a database from scratch that can handle basically infinite growth and is 100% available? Core services, like your shopping cart, simply could not go down. This wasn't about a simple upgrade. No, this was about a complete reinvention. And at the heart of it all was this fundamental clash. The old way of managing data was hitting a brick wall against the new demands of the internet age. And yeah, the old tools were starting to shatter. Just look at the difference here. It's pretty stark. On one side, you've got your traditional databases. They're kind of rigid, they're really hard to scale out, and this is the big one. They often have a single point of failure. If that one central piece goes down, the whole system can just collapse. Then you look at what Amazon needed: extreme, unpredictable scale and absolute non-negotiable availability. The two were just never, ever going to work together. So, faced with this impossible problem, Amazon's engineers didn't just slap a Band-Aid on it. Nope. They created a blueprint for a whole new generation of databases. And they built an internal project to do it, called Dynamo. At its core, Dynamo was built on a beautifully simple idea: a key value store. Forget about complex tables. Just think of it like a giant, super fast dictionary. The key could be your shopping cart's ID, and the value is simply the list of items you've added. The system's only job is to find that key and give you back the value, instantly. That simplicity, that's the secret to its incredible speed. The other crucial piece of the puzzle was making it a distributed system. So instead of putting all the data on one giant, expensive supercomputer, they spread it out across a whole fleet of normal, cheaper machines. And that right there is how you eliminate that single point of failure. If one machine goes down, who cares? The system as a whole just keeps on chugging along. And you can see how this all played out on the timeline. The crisis hits in 2004, which sparks the creation of Dynamo. Then, and this was a huge deal, in 2007, Amazon publishes a paper explaining to the entire world exactly how they built it. Finally, in 2012, they take all those battle-tested ideas and launch DynamoDB as a public service on AWS. Suddenly, its power was available to everyone. And look, I can't overstate the impact of that 2007 paper. It wasn't just some boring internal document. It was a bombshell in the tech world. It provided the blueprint for a whole new category of databases we now call NoSQL. It inspired iconic systems like Cassandra, the database that would go on to power Facebook and so many others. Okay, so this brings us to the next phase of the story. With the public launch of DynamoDB on AWS, what was once Amazon's internal solution became a foundational building block for the entire internet. So why do developers love it so much? Well, it was built on 3 killer principles. First, elastic scale. You need more capacity? You just click a button. Second, predictable low latency. We're talking response times measured in just a few milliseconds. And third, and this might be the most important one, zero operational overhead. It's serverless, which means developers could finally focus on building their apps, not managing database servers. So how does it actually do all this? How does it work? All right, let's pop the hood for a second and take a look at the architectural choices that make this incredible scale and resilience even possible. The secret lies in a famous computer science idea called the CAP theorem. It basically says any distributed system can only guarantee 2 out of 3 things: consistency, availability, and partition tolerance. You have to make a trade-off. DynamoDB makes a very deliberate choice. It picks availability and partition tolerance. This means the database will always be online and ready to answer. The trade-off? Data consistency might be slightly delayed, a concept we call eventual consistency. But for a shopping cart, it's way better to always be available than to be perfectly consistent but sometimes just down. And all of this power is delivered through some incredible features. It's serverless, so you manage absolutely nothing. It automatically partitions your data, spreading the load for you without you even thinking about it. With global tables, you can copy your data all over the world for lightning-fast access anywhere. And while it defaults to that eventual consistency, it also gives developers the choice to demand a strongly consistent read when they absolutely need it.
So why does all this technical stuff matter to you? Because this architecture isn't just theory. It is the engine running behind many of the apps you probably use every single day, and you don't even realize it.
Oh yeah, when you ask Alexa a question, you're using DynamoDB. When you're browsing for a movie on Prime Video, you're using DynamoDB. Swiping on Tinder, accessing files on Dropbox, or booking a stay on Airbnb, all of it is powered by the speed and scale of DynamoDB. It's one of the internet's invisible giants.
And its use cases are incredibly diverse. It's a dominant force in any industry that needs massive scale and real-time performance. From the leaderboards in blockbuster video games and data from millions of IoT devices to the back end of your favorite mobile apps, DynamoDB has become the go-to choice. When you step back, it's really an amazing story. What started as a desperate solution to an internal crisis at Amazon became a global revolution. DynamoDB didn't just solve Amazon's problem. It fundamentally changed the rulebook for how everyone builds scalable, high-performance applications for the entire world. It's an incredible story of innovation born from pure necessity, and it leaves us with a fascinating question to chew on. The amount of data we all create is only going to keep growing, exponentially. So what comes next? What's going to be the next great database revolution that powers the applications of tomorrow?